You know, what if I told you that some of the most powerful medicines we have actually come from molecules that evolution designed specifically to kill? It sounds crazy, right? But today we are diving deep into one of nature's greatest paradoxes, how we're turning the deadliest poisons into literal life-saving cures.
So think about that for a second. Could the world's most dangerous animals also be our best doctors? It really does sound like something out of a comic book. But the answer, believe it or not, is a huge yes. From the bottom of the ocean to the middle of the driest deserts, it turns out the animal kingdom's chemical weapons, well, they're stocking the shelves of our most advanced pharmacies.
All right, so our first stop on this journey is in the warm waters of the Indo-Pacific, and we're looking at something that, at first glance, is just beautiful. The cone snail. You know, if you saw this shell on the beach, you probably think, wow, what a gorgeous find. But here's the thing, picking it up could actually be a fatal mistake. So here's the secret sauce. It's all about precision. The cone snail's venom, it's not just one big poison. It's actually a complex cocktail of hundreds of different compounds. Think of each one as a tiny, highly specialized missile aimed at a very specific part of the nervous system. And that's where scientists had their big aha moment. They figured out that if they could just isolate one of those little missiles, they could use it to block the exact channels that transmit pain signals to our brain. It's like finding the one key that fits a single crucial lock. And when I say it works, well, the result is just staggering. The drug they created, called ziconotide, comes directly from one of these venom peptides. And get this, it can be up to 1,000 times more potent than morphine. Let that sink in. 1,000 times. That's an absolutely unbelievable level of power, and it comes from a little creature that barely even moves. But here's the truly revolutionary part. This is the big one. Unlike morphine and other opioids, ziconotide completely sidesteps our opioid receptors. It doesn't touch them. And those receptors, well, they're the very things in our nervous system that can lead to tolerance and, worse, addiction. That is the critical difference. You get this incredibly powerful pain relief, but without the devastating risk of dependency. It is an absolute game changer for people suffering from severe chronic pain. Okay, for our next case, let's head over to the American Southwest. Here, we're going to meet our second unlikely doctor, the slow, kind of stocky Gila Monster. Now, this lizard is pretty famous for its sluggish, lazy lifestyle, but believe it or not, its venom holds a key secret to fighting one of the world's fastest-growing diseases. So check this out. The Gila Monster only needs to eat like 3 or 4 times a year. To pull that off, it has a compound in its venom called exendin-4 that basically supercharges its metabolism, making it incredibly efficient. And it just so happens that this exact same compound is a near-perfect mimic of a human hormone called GLP-1. That's the hormone that tells our pancreas, hey, release some insulin. The big difference? The lizard's version is way tougher and hangs around in our system for a lot longer. And the path from this discovery to your local pharmacy is just incredible. It starts in the 90s, when scientists first identified this peptide. By 2005, it's already launched a whole new class of drugs for type 2 diabetes. And today? Well, today, that same class of drugs includes blockbuster names you've definitely heard of, like Ozempic and Wegovy. We're talking about some of the most prescribed medications on the entire planet. All of it traced back to a slow-moving desert lizard. Wild. All right, now for an animal with a name that, well, it doesn't exactly make you feel warm and fuzzy inside. The Deathstalker Scorpion. Yeah. Its venom is one of the most dangerous on Earth. A nasty cocktail of neurotoxins that can literally cause heart failure. And yet, hidden inside that deadly mix is a tool that is helping surgeons save lives in the operating room. And here we go again. The secret is that same word, specificity. There's this one peptide in the venom called chlorotoxin, and it has this just unbelievable ability. It sticks to brain tumor cells like superglue, but at the same time, it completely ignores healthy brain tissue. It's basically a molecular GPS system that hunts down and flags only the cancer cells. So you're probably wondering, how does this actually work in a hospital? Well, it's genius. Scientists take that peptide, that little cancer-seeking missile, and they attach a fluorescent dye to it. Then, this compound gets injected into a patient before they go into brain surgery. And then, in the operating room, the surgeon flips on a special near-infrared light, and bam, the tumor literally glows. It lights up, showing the surgeon precisely what needs to come out. Just try to imagine the impact of that for a second. One of the absolute biggest nightmares for a brain surgeon is figuring out where the tumor ends and the healthy brain begins. It's this razor-thin margin. If you take too little, you leave cancer behind. If you take too much, you could cause permanent, life-altering damage. This tumor paint, derived from scorpion venom, helps solve that impossible problem. So, okay, we've looked at a snail, a lizard, and a scorpion. But these are just 3 examples, and they all point to a much, much bigger idea. We're not just getting lucky and finding a few useful molecules here and there. What we're actually realizing is that the venom from the world's deadliest creatures, it's like one of the richest, most complex, and most powerful pharmacies on the entire planet, just hiding in plain sight. Just think about the cone snail for a minute. Just that one animal. There are hundreds of different species of them. And scientists estimate that across that entire family, they might hold over 100,000 unique, unstudied compounds, little molecules that could interact with our biology in powerful ways. And we have barely even scratched the surface. It's like finding a massive library with 100,000 books, and we've only opened 1 or 2. And you better believe the search is expanding. I mean, right now, as we speak, scientists are studying venom compounds for, well, just about everything. They're looking for new addiction treatments, better local anesthetics, novel drugs for seizure disorders, even faster-acting insulin, and ways to stop cancer from spreading. Literally every venomous creature out there is a potential source for the next huge medical breakthrough. Which, brings us to a final and pretty urgent thought. So many of these animals, like the cone snails we started with, they live in incredibly fragile ecosystems like coral reefs. And those reefs are disappearing at a terrifying rate. So it really forces us to ask this critical question. For every cure we've managed to find in nature's pharmacy, how many more are we destroying before we even have a chance to discover them? Something to think about.